Alright, welcome back to another episode. Today we're actually going to be talking about PLC programming, and in particular we're going to be talking about analog scaling. So as you know, if you're familiar with PLCs, we use analog sensors and signals to, of course, transmit information. The thing about analog like sensors, whether it's a temperature sensor or something else, a pressure sensor, generally they come with a very high value, so anywhere from like 0 to 30 plus thousand. So when we want to use these analog signals, a lot of times we actually have to scale the signal. So if we just want to scale it, for example, from instead of 0 to 30 something thousand, we might want to scale that from 0 to 10 to maybe represent voltage. So that's actually what we're going to be doing today. As you can see here, in my office, I have a PLC trainer that is an Allen Bradley Micrologix 1100. That particular trainer is from Industrial Concepts. You can go to their website. They have a very wide selection of different PLCs and PLC trainers, where if you want to learn PLC at home, I would highly recommend actually buying a real PLC and then using maybe like a free software. So with that being said, we're also going to be using RS Logix 500 software, but keep in mind that this will also work with RS Logix 5000 and Studio 5000 software. So in particular, we have a little potentiometer knob on here. I don't know if you can see it, should be on your left. Just a little potentiometer knob. And then we also have an actual voltage output here from 0 to 10. This is going to represent the actual voltage. So instead of scaling 4 to 20, which would be like a current scaling, we're actually going to scale it from 0 to 10 volts. So with that being said, we're going to go ahead and hop on into the actual software and start programming this thing, and let's get this scaled for today's video. Okay, so I am communicated with our PLC now. As you can see, if I turn the potentiometer knob, our voltage actually goes up. So we'll actually be looking at our program and seeing how exactly this works. So of course, this move instruction, as we said before, that's going to be our potentiometer to our output destination, which in our case is our voltage gauge from 0 to 10. Keep in mind, I'm not going to show y'all how I set up the analogs. I'm not going to show y'all how I set up the 0 to 10, or if you were to use like a 4 to 20 as for current analog scaling, maybe that can perhaps be a different video. But for right now, we're just going to explain this. So the move instruction, that's going to move the values, or what's happening between the potentiometer and the gauge, and kind of interlink those. Next is our scale with parameters. So we're going to take our input, and that's going to be, our minimum is going to be 5, and our max is going to be 1023. As I said at the very beginning of this video, depending on what analog you're using. So if you're using a temperature sensor, or what size analog you're using, you will have different values. They can be as low as 1,000, or as I said before, they can be as high right here as 32,000. So our low value here, as you can see, this is all the way off, is not 0 for our particular case. It's actually 5. So we tested this at the very beginning. You can test this by just going to your input, of course, change this over to decimal, and you can see we have our 5 here as our analog. If we power this all the way on, you can see we're stuck with our 1023. So this was tested, of course, beforehand. That being said, we're going from 5 to 1023, and we are going to scale that the same as our voltage, going from 0 to 32,767. This will make sure that when that potentiometer is turned all the way on, that our voltage being sent to our output, so our 10 volts is 10 volts. It's going to make sure that our gauge is also maxed out. We turn the potentiometer halfway, we're going to make sure that it goes halfway, as you can see. Back down to 0. And of course, this is just specifying this going to the output 1.0. As you know, that is our voltage output gauge. Our next scale, which we want to see, is we're going to take this output voltage, so whatever is actually happening on our gauge. This, of course, will be scaled from 0 to 32,767. That is because that is the number, that is the number that we have. That is our max number for that particular analog output. We are going to scale that, so we're going to go 0 to 32,000, which is, of course, 0 all the way to our max voltage. And we're going to scale that from 0 to 10 because we have 10 volts here. So when we go, halfway between 0 and 32,000, like 16,000-ish, you can say right there, 16,000-ish, as you can see on the screen, you can see that puts us pretty much at 4.95, and some change. So that's actually going to be half of it. That's 5 volts. If we max it out, you can see we are going to max it out right down here at 10. And as you see, as I turn, this value changes. So 0 to 10, and we're going to actually send this to an actual float destination. This is our F8-1, so if we go in here, you can see we have our 0, and we also have our 10. So we have that as our voltage flow. Now, of course, the last thing that you'll notice is that we have some lights turning on. Our red light turns on, and you can see we have a little less than here, and we always reference our F8 now because that is where our 0 to 10 voltage is being stored. Of course, you can store it anywhere you want to, but anything, so if F8 is 2 or less, so 2 voltages or less, or 2 volts or less, so if we go up to 2 here, it turns off, but anything less than 2, we're going to throw up this red light. That might be like an error light if the voltage drops. So that's set up. We also have a greater than, or if it's greater than 9 volts here, it'll turn on, of course, the green LED. And if we count up to 10, so say if we have 10 spikes here, we'll have the blue light turn on here. Count up timer here. We see we have 10 counts where the green LED turned on 10 times. That turns on the blue light. So maybe you have to reset that. In our case, our reset should be this switch. Yep, it'll actually reset that for us. I hope y'all enjoyed this video. If y'all have any more questions, please do not hesitate to put a comment in the section below. Of course, I am not a super professional in the controls world. We are always learning. In the PLC world, you are always learning, so I'm sure there's multiple different ways to accomplish what we did here today. But please, go home, download software, or play around with your previous existing software, practice, and leave a like on the video. Thank you all so much, and I will see you next time.